This is the Uploading Files with Blazor mini course. So far, we've seen how to upload one or many files and how to associate files with form data. Now, we'll want to capture that information into a SQL database. Along the way, we'll have a discussion about the upsides and downsides of storing files in a database versus storing files external to the database and linking them to our data. This video is part of a mini course around uploading files. I would encourage you to click on the playlist link in the description and use it to go through the course in order. Now, if you don't know me, my name is Tim Corey, and it's my goal to make learning C# easier. I have hundreds of videos here on YouTube with more coming out each week. I have a podcast answering questions developers have, and I provide training courses designed to give you the real-world training and experience needed to succeed in today's marketplace. You can find all the resources I have to offer at IamTimCorey.com. Okay, let's jump right over to our Visual Studio. And again, we're picking up where we left off in the last video. Now, if you've been following along, or if you got the source code from the last video, you should be set to continue from where we left off. Because we haven't changed anything from the previous video, we're now going to pick up right from where we left off and keep going. That does mean if you're just watching this video to understand the SQL part of it, that's fine. Feel free to stick around. You'll just have to either get the download from the previous video if you want to follow along, or just watch and see what I do, and then see if you want to jump back and watch the entire series. Okay, I've broken the series up in order to give you that option of either watching just the piece you need or of seeing the thing in its entirety. Okay, so let's talk about uploading files. And we've got the files are actually uploaded, but now we need to work with the SQL database. And to do that, we're actually going to go over here to SQL Server Object Explorer. And if you don't have this installed, you probably don't have the SQL database tools installed. You can go to Tools, Get Tools and Features, and make sure you have the data tools installed. But under the View menu, you'll find the SQL Server Object Explorer. You can open that up, and it's going to give you one or more local DB projects. These are test databases only. They're files that act as SQL databases. And we're going to create a new one. I've got a whole bunch of test ones in here already. Notice we got a bunch, most of this, delete me, test, so on. But we're going to create a new one. And we'll do that in just a minute. But we also need to create a class library to talk to this. We're going to create a data access library. I'm not going to use Entity Framework. If you've watched any other videos, you kind of know why. But if you're new, the reason I'm not using Entity Framework is a long history. I've got a whole video on Entity Framework best practices. And one of those best practices is that you really need to know both Entity Framework very, very well and also SQL very, very well in order to effectively use Entity Framework. And there's a lot of work that goes into it to doing it right. It's very easy to not do it right, but have it still kind of work, but it's hard to get it right. And so I tend not to do that. I tend to use Dapper because it really kind of forces your hand a little bit and makes sure that you understand how to do things right the first time. So that's what we're going to do in this video. So let's create a new database. So just add new database. And we're going to call this database file upload, just DB, just to have a name for it. It doesn't really matter what you call it, but it's there so that you know what's going on. And then we're going to create a new table. And we're going to do this right inside of Visual Studio. You can do it different ways, but I think this works well. Just know there is a project type inside of Visual Studio called SQL Server Data Tools, or SSDT. And what it allows you to do is actually create your database structure, the schema, inside of Visual Studio, put in source control, have things like rollbacks, or upgrades. So you upgrade your previous database version to the new one automatically using source control and CI/CD. You can, if you make a change to a table name or a file name, a column name in your table. There you go. If you make a change to the column name, you can actually update everywhere that column is used. So all the store procedures, all the views, and so on. Really good stuff. We're not using that here. We're just using the tools to generate a quick and dirty database. So we've got this ID here. I'm going to make it an identity. So I'm just going to say identity. This is one of the nice things with these tools. You can use the GUI up here. You can use the text down here, or you can even use the properties over here. So with all these options, which one you choose is up to you. Basically what this identity does is we can say, is identity true, increment by 1, identity seed is 1. That's what this one keyword did, which is why I love having all three options. Because instead of dialing this specific thing, expanding this out and saying true here, I just type identity and I'm done. So what is this? What it means is that the ID field, we never actually put a value into it. It handles creating the value, and it starts at 1 and it counts up. So 1, 2, 3, 4, and so on. And that will generate for us a unique identifier to identify the record that's easy to track, it's easy to remember, it's easy to use, and it is in order, which actually makes putting it into new records into the database a little more efficient. Because not, a GUID is also unique, but what happens is every time you insert a record, it has to figure out where to put that on disk. It has to kind of insert it and move things around and so on. With an auto incrementing ID, it doesn't have to do that because it's ordered by that identifier. Therefore, the latest one is the last one, which goes at the end. So, little fact there. Now, this is how we're going to identify our records. Also note that if you restart your computer, it restarts SQL, which means that it will put a gap in the identifier. So you might see the identifier goes from 1, 2, 3 to 1004, 1005, and so on. And it might jump a few times like that. That's okay. Don't worry about it. Don't try and reset it. Don't try to figure out how to fix that. It's not something to fix. That's designed that way to protect your data. We're not going to go into that now, but just note those numbers. It doesn't matter what the numbers are, so leave them alone. Okay, let's change the table name. We're going to change this to customer, and we're going to say we have a few fields. First name, let's make it nvarchar of 50. Last name, nvarchar of 50. Again, nvarchar means that it uses Unicode, so you can have more characters. This checkbox here means it allows null, so you have a null value, and 50 is the number of characters we're allowing. It's the maximum number of characters. We're going to leave it alone. That's probably fine for most cases, but everybody needs to choose whatever field length works best for their situation based upon their data. So something to think through, but for us, I think that's fine. We're also going to have the file name, and we're going to do nvarchar here, but we're going to do 2000 because I believe a file name and path can be up to 2,000 lengths or 2,000 characters in length. Okay, so we're going to have our file name, and let's grab the username too. So that's the tcorey. That's going to be we'll use nvarchar50 for that. That's tcorey, whoever's logged in. We're just going to capture that to know, hey, who was the user who created this customer. So again, it's hard coded for us because we're not using an authentication system. So that's all we've got going here, and we can actually make sure that we update this. Now, this is one area where it's a little quirky, and I'm not quite sure why. I haven't figured out why yet, but for whatever reason, if I were to say update here, it's going to take my Visual Studio a little bit of time. I'm not sure why, but if you right-click and say, and your database and say new query, and then come back over here and copy this create table, it's all you need. Copy it, come over here, paste it in, and use this run button, execute. To execute that, it executes immediately. Don't save it. Don't save this. But now if you go to tables, we'll see we have that customer table there. It's a quirk. I'm not quite sure why it does that way. It only happens when you're doing things with just directly here as opposed to using SSDT or something else, just so you know. So with that, the other thing we're going to create for this lesson is we're going to store this data in the table. So let's go ahead and go to Programmability, Store Procedures, and say New Store Procedure. Now, I use store procedures all the time. And one of the big reasons why is because if I only use stored procedures, I can further lock down my connection string. That's very, very important to me, that I have the least amount of security hole in my database. So when you have a user in your connection string, it says this user is authorized to access the database. I can say yes, but only for calling existing stored procedures, not for creating tables, not for deleting records that it's not allowed to, and so on. So I've got a whole video on stored procedures and why they're valuable, but we're going to use this stored procedure and call it customer underscore insert. So with this, we need to bring in all of the columns from the customer record. So we're going to say ID int, and we're going to say first name and varchar 50. Just match up whatever the values are for the types here. So last name and varchar 50. File name and varchar 2000. And username and varchar 50. And then the other thing I like to do is start at the begin and have an end. This defines the scope of your stored procedure. That way it's very clear what the scope is. And it's just one entry here. We're going to say insert into dbo.customer. We're going to say first name, last name, file name, and username. Now, if you note here, and let's unpin this, now we don't need it anymore, the file name is in blue. That's because it's actually a keyword in SQL as well, but we can surround that with square brackets, and it's just fine. And we don't technically need to surround it in square brackets. It would still work, but we're going to be as clear as possible. So first name, last name, file name, and username. Now, I did not use ID. And what I'd do here normally is I'd make this into an out value as well. So it wouldn't take any value in, but it would take a value out because we don't actually update this ID. We don't change it by when we insert. We let it alone. We leave it alone because it's going to generate that number automatically. But at the end, I could get the ID that it generated and pass it back. And you can do that with Dapper. But in this case, I'm going to leave it alone. We're just going to leave it like this. So we're just going to pass it in and not actually use it. So we're going to execute. And that created the store procedure. So now if we look over here at our store procedure list and open it up, we now have that one store procedure. Don't save that. Okay, we don't need to save it because that's just the query window is all it is. The actual object has been saved. So if you're not familiar with SQL, but you want to be more familiar with SQL, I do have a full course on being a SQL developer and how to create tables and views and store procedures and why we do things, and how to back things up and restore things and all the rest. So just in case you need a fuller profile, but I do have stuff on YouTube as well that would be helpful. Okay, so now we have our table, we have our store procedure set up. We now need to add a class library to our solution. So I right-click to my solution, we're going to say add new project. We will choose class library, and we'll call this upload files library. I like to call my class libraries library at the end. That way you know when you're trying to reference, you only reference libraries. Just a little shortcut there. All right, .NET 7, yes, that's what we want. We hit create. We're going to delete class 1. That does mean I can't add a reference yet to my library because of the fact that there's nothing in my library to have a namespace. So we'll get there in just a minute. But first, we need to right-click and say manage NuGet packages on my class library. And we're going to install a few NuGet packages. First one, Dapper. All right, and if you scroll up one, I think it's someone had a suggestion, maybe my zoomed in text. I'm not sure, but for whatever reason, when I first load in Dapper, it loads in like this. And Dapper's missing. That's because you have to scroll up. For some reason, it's not showing the very top of the list, at least for me. And it happens on multiple machines that I use. So it's not just machine specific. It might be font size specific though, because I do have a zoomed in font for recording. Okay, so we're going to choose Dapper, which the current version is 2.0.123. You choose whatever the latest version is for you. We hit install, hit OK. And we're also going to set up or ask for Microsoft.data.sql client. This is the, there's also a system.data.sql client, but this is the later version. This is the newer version of SQL Data Client. So we're going to hit install on this. And that's the latest version is 5.0.1. So, and then also we need Microsoft.extensions.configuration.abstractions. All right, that's the top one right here. This is some abstractions for talking to our configuration. Okay, so let's install this. And I'll talk through these three packages and we'll talk more as we use them. But the three packages we have installed are, now let's ignore transitive for a minute. But the three packages are Dapper. This allows us to talk to SQL. It's a micro ORM if you're not familiar. Basically, it doesn't do any of the extra stuff. It just allows us to pass in a store procedure or a SQL query of some kind and get back the data, and it puts it into a strongly typed model. That's all it does. But because it just does that very, very simply, it's very, very fast. And that's all we really needed to do is just say, hey, run this SQL, give me the stuff back in models. And that's a huge deal. It's much better than just doing a straight ADO.NET, which gives you back a data table that you then have to cast over to the right types to create models. It's a little messy. This does it for you. Very, very clean. So it's not going to do the things that Entity Framework does, just write a link query and have it be the query to your database. But you can use link on the data that came back. So if you want to do that, you could, but link is not very efficient. So I'd recommend you let SQL do what SQL does itself best, which is querying, sorting, and filtering, and then take the data into C# as close to what you need as possible, and then just manipulate what small bits you need after that. So that's what Dapper does. The Microsoft.data.sql client, what it does, it allows us to connect to SQL Server. So Dapper uses this to connect to SQL Server. Just so you know, Dapper doesn't just do SQL Server. It does MySQL, SQLite, SQL CE, Firebird, and a lot more. So we're using the SQL client from Microsoft to connect to SQL Server. And then finally, this allows us to talk to our configuration. So Microsoft.extensions.configuration.abstractions allows us to talk to appsettings.json and all the other ones too. If you're not familiar, appsettings.json is not the only place you put configuration. There's also appsettings.developer.json, and we have secrets.json, and we have environmental variables, and we have the command line parameters. We can even pull in things like Azure Key Vault and so many other places to pull in data. And this allows us to talk to that set of locations very, very easily to reference things. So that's in our class library. It normally is in the UI projects, but we're not using it from the UI project. We're using it in the class library. That will raise a question of, where is the app settings.json in the class library? Well, class libraries don't have their own settings. Instead, they pull from whatever UI project needs them. And so in this case, we'll pull from the app settings of upload files app and its app settings. So just note that's where they're going to come from. Okay, that's all of the packages we need. Just so you know, if you went and looked at the library, you'll see there are the three packages that have been added. So that's where they're at in case you were wondering. Okay, so now let's create, and right in the root, we're making this clean and simple. So we're not going to be, let's close all of these. We're not going to be, creating this really cool file structure. We could do that in Bear project. This is a demo project. So we're just going to put right in the root a new file. So let's add a class in the upload files library called SQL data access. And we'll make this a file scope namespace, and we'll get rid of our using statements for now and make it public. And in here, we're going to create a constructor, CTOR, and we'll ask for an I configuration. And that's going to add a using statement for Microsoft.extensions.configuration. Okay, that's the one we need. And we're going to say config. I'm going to do control dot to create and assign the field _config as a read-only field. What this does is it allows us to use this class with dependency injection where we ask for an I configuration. That's the thing that allows us to talk to app settings.json and others. So we're asking for that variable in, which comes from dependency injection. Then we're going to capture that variable as a private read-only value so we can use that throughout the rest of our class. So let's create the one method we need right now, which is public, if I spell it right, async task save data. And we're going to say string stored proc, string connection name, and object parameters. All right, we can, let's put our curly braces here, and then let's see if we can quick actions refactoring to wrap every parameter, and we'll indent them all. That way it's on the screen at once. So this save data method, which is going to just save our data to SQL. That's all it's going to do. We're asking for three things: a store procedure name, the connection string name, not the connection string, just the connection string name, and then any parameters for that store procedure. This will allow us to safely protect ourselves against most forms of dependency, or SQL injection. We don't want to create a SQL statement dynamically on the fly. That would be vulnerable to SQL injection. This will prevent a lot of those by using parameters instead. So we're going to first get the connection string. String connection string equals _config dot get connection string, and it already knows what it is, connection string name. Now, this is where we have some help with the nullable. So if you look at your project, you'll see that in the project there is this nullable thing here, and it says enabled. This is a newer thing in, I believe, .NET 6, maybe. What this does is it says, hey, your project is going to use the nullability. And what that is going to do is going to give you some warnings when you're not declaring this string as nullable, even though, yes, a string can be null. And even though it's not marked as nullable, if this came back as null, it would successfully put null into this value because a string can be null. However, we have not specifically said this string can be null. So therefore, since we haven't said that, but it could be null, it's warning us and saying, hey, you know what? You're not properly planning for things because this could return a null value and you haven't planned for it. So what do you want to do? Do you want to mark this string as nullable, or do you want to do something with this value to make sure it's not null? Because if you ask for a connection string and it's not there, you'll get a null value. Well, in our case, if you returned a null connection string, what should happen? Well, we shouldn't go any further because you can't connect to a database if you have no connection string. Therefore, I want this to throw an exception. Now, I could make this nullable and then do a check to see if it's null, and if it is, then throw an exception. But I could also do this. I'm going to put on the next line 2 question marks. And what this is, the null coalescing operator. And what it's saying is, hey, if the first value is null, then put whatever the second value is in instead. So I could put, for example, that. And what that would do is say, hey, here's the default value. But we're not going to have a default value for connection string, so that wouldn't work. We want to instead throw an exception if the connection string is null. So we're going to say throw new exception instead of putting a value here. And we're going to say missing connection string at connection string name. Now let's unpin this so you can see the whole thing. And what this will do is it will throw a exception now if we don't have a value for our connection string. Now, normally this would be a value that goes into our string, but you can throw an exception pretty much anywhere. And this is a case where we want to throw an exception if the first value is null. Okay, so now we know for certain after this that the connection string is not null. Because if it is null, we won't go any further than this. We'll just throw that exception. So now, using var connection equals new SQL connection. This comes from Microsoft.data.SQL client. So I have to add that using, which just got added automatically right there. Oops, sorry, right there. So the SQL connection takes in a connection string, which is not null. And there we go. We're going to create a connection to our SQL server. This is not Dapper. This is just Microsoft so far. And we're using the using here so that when we are done with this scope, meaning these curly braces right here, when you get to the last curly brace here, that's the end of this scope. And at that point, it will successfully and it will call the disconnect from SQL method, the dispose method on the SQL connection. That way, we properly shut down our connection no matter what. And we make sure that we don't leave open connections that would cause our server to slowly bog down and lock up. So that's important. And we're going to say await. Connection dot execute async. This is going to add another using statement, this time for Dapper. So execute async. We're going to pass in the stored proc, the parameters, and we're going to say the command type is system.data.command type.store procedure, which that's a little long. So let's go ahead and wrap this using our quick actions refactoring. We're going to indent all arguments like so. So now that's all there is to our execute. So what does this do? Well, it takes in a store procedure. So that name is going to be dbo.sp customer underscore insert. So it's going to pass in that insert method. It's going to pass in the connection string name, which that's the name of our connection string in our app settings.json. And it's going to find the connection string. And we're going to pass in these parameters. Those parameters are going to be the first name, the last name, the file name, the username, and the ID. We'll pass those in. We'll execute it, meaning we'll run that on SQL and be done. So whenever we use this, we'll just say save data, pass those three values in. We're good to go. That makes our using of Dapper very, very easy. So with that, I think we're done with this. Now what we need to do is I'm going to create an interface for this. So I'm going to say control dot here or right click and go to quick actions refactoring, extract interface in that same file. Notice it's going to say which members do you want to add to your interface. Just leave all of them checked, which is only one. Hit OK. And that creates now an iSQL data access, which we can see over here in our Solution Explorer right here with the one method. And you may say, let's put our semicolon here. You may say, well, Tim, why was it even necessary? Because it's just creating an interface to create an interface, right? Well, no, we're going to use this in dependency injection. We're going to say, hey, whenever you ask for an iSQL data access, give you SQL data access. But again, why would you add that level of abstraction when we're just going to ask one-to-one? There's not going to be a different SQL data access. And the reason why is because this allows us to very easily replace this when we're doing unit testing. Because we have an interface, it's much easier to mock an interface and say, hey, here's the interface that you need. We could create a new class called SQL Data Access and override it and all the rest. We don't need to. We can just use a new class that inherits from iSQL Data Access and use that instead of SQL Data Access. So that's why we're doing that. So we go over to our Upload Files app, which is our Blazor server app. We go to program.cs. This is where dependency injection gets configured. So we're going to say builder.services.add singleton. And we're going to ask for iSQL Data Access and say SQL Data Access, which it's like, I have no clue what those are. No problem. I believe the control dot does allow us to do that. It does. It's control dot's awesome. If we typed it right, notice add reference to upload files library, right? And it will also add the using. So I'll do that. Click on it once, and we're done because it added the reference to the upload files library. But if you want to do it manually, you go to dependencies, right click and say add project reference, check the box for upload file library. Once you're done, then add the using statement for upload files library, and then you'd be good. So the quick actions refactoring makes our life a lot faster and easier. So that's all we have to do in that setting. Now we're not quite done here because we need to go to appsettings.json, which does not have a section for a connection string. So we hit comma and say connection strings, plural. Notice it already has this as part of IntelliSense. That's because this is a standard section. We are going to use it as a standard section. We want to say default, and then put a connection string in here. Now, you could call it anything you want. We could call it the name of the database. We could call it something else entirely, TimDB. Doesn't matter, but we're going to use default just because we've chosen to. But what's the connection string? And here's where people often get tricked up. The connection string is dependent on your machine. So when you download the source code, which you can use the link in the description, download the source code. If you just try and run it, it's going to give you an exception. It's going to say, I can't talk to the SQL database. I can't find a SQL database. And you're going to say, Tim, this is broken. And it's not broken. What happened is that it's trying to connect to my SQL database, which you don't have access to. This connection string is unique to your computer. So you have to make that change. So here's how to do it. You go to the database you created. Now, if you've created a separate database on an actual SQL server, it'll be different for you. But I'll show you the parts of it that you need to know about. But this is the easy way. If you're in SQL Server Object Explorer, you select the database. Then you go over to Properties. And if you look down here, there's a connection string. If you just double click in the value and hit copy, then come over here and hit paste. It's going to put the connection string in for you. Now this looks very big and scary. Don't worry, it's not nearly as scary as it looks. So let's talk through the parts of it that you need to know. First of all, data source. This is the name of your server. In our case, our server is called localDB in parentheses / MS localDB. That's the name of our server. If you look over here, localDB / MS SQL localDB. That's the name of our server. So if your server was called something else, you put that name in there. If you're using a full SQL server that you installed, typically the first instance of SQL on your machine is you can reference it by saying dot. That's it, just dot. Now, initial catalog. This is the name of the database. Now, it's initial catalog because you could actually access other databases, but by default, it's going to default to this database. Well, that's our database name right there. And then integrated security equals true. This means that it uses my credentials that I've logged into Windows. So since I'm logged into Windows, it says, hey, we're going to use the fact that you're logged in to also authenticate you to the database. Now, by default, you are the admin of databases that you've installed on your computer locally. So therefore, integrated security equals true will make you the administrator. You're good to go. However, when you're connecting to a remote SQL server, you're more likely to be using an actual username and password, which is what we're to replace this. So you have a username and a password. And yes, that password will be in clear text. And that's not really a security violation because of the fact that the user already can access that, even if you encrypted it, just so you know. We have a whole other discussion on that and other videos on my YouTube channel, but that's just so you know. So if they can access your connection string, they can access your database as that user. Now, the rest of this stuff, yes, it adds some things to it, but you don't have to have any of this stuff. You can actually delete it all. It would still work. So just know those are the three parts. If you're connecting to a separate or a different database, you might use a dot here and then your database name here. And then if integrated security will work for you, then that would be all you'd need, or you'd need a username and password here. Either way, that'd be all you'd need to connect to your database. If you go to, I believe it's connectionstrings.com, there's connection strings for a whole bunch of different types of servers, not just SQL, and it will show you the structure of how to set them up and what things to put where. But that's it for us. Now, I am storing this in appsettings.json, and that's not typically where we put our connection strings. In fact, I would encourage you not to do this in a real application. I'm putting it here so you have access to it so you can see it when you download the source code. But what would happen here is this would upload to source control. And then your local database is what the connection string is for, but only you have that database. No one else does. So when they download the source code, it won't work for them. They have to change this, but now that's a change in appsettings.json, which gets put in a source control, which means now your database won't work when you sync changes. It causes a mess. You don't want to do that. Instead, you want to use secrets.json, which is a local connection string place or a local place for settings that is only on your machine, does not get uploaded to source control, that will override appsettings.json. You can get there by right-clicking on your project and saying manage user secrets. So you can put the connection strings there. It would override the connection strings you have in appsettings.json. I cover more about this in my course. I have a whole course on app settings because it's so much to cover as far as the 5 different places you can do, plus others you can add, and how to set this thing up to do it really well to make the most of your settings. So for now, though, we're going to put it in appsettings.json because you can download the source code and have this to see the structure of what mine looks like, even though it's going to be different for your machine. You have a place to look at to start. Okay, all that explanation being done, we've got this in our dependency injection. We have it in appsettings.json. We have our library. So now it's time to actually start using this. And to do that, it's kind of simple. So first we're going to add a using up here. We're going to say support library. And that, not support library. We call it upload files library. There we go. And that's going to reference our other library. So we have to add upload files library dot every time you want to access something from there, specifically the SQL data access. Inject SQL data access. We'll call it SQL. Let's use a dependency injection to get that connection to our SQL server. So we've got all of the edit form information already. That's already done. So now we just need to come down here to our source code and actually do some work. Now, one thing I didn't do before, max files allowed. We don't need that. We're only capturing one now. So we can leave that alone. But let's go ahead and update this submit form. We have the model. I'll show you how to save this to SQL Server. Await SQL.SaveData dbo.sp customer underscore insert. That's our store procedure. Default is our connection string name. And the parameters, new customer. And that was an object, but we're passing in the customer model, which has all the data. And Dapper can use that, since we're using the same parameters, can use that to create the parameters for our store procedure. So guess what? This line right here is all we had to add to save our SQL data to SQL Server. We're done. Now, we're going to add a few more lines to kind of clean things up. So we're going to say new customer equals new. That's going to reset that customer model after we've uploaded it. We're going to say that file equals null. That's our iBrowser file. So once we've uploaded, let's clear that file out. And we'll also say errors.clear when we're done. Okay. We should also probably clear the errors when we are submitting this form for the very first time. So that way, if we generate errors, they're brand new errors. So that's all we need to do to have our insert done. Let's verify that. Let's actually run this, make sure it's going to work. So let's go to run this application. We'll also bring over our temp storage here. So we don't have any records in SQL yet, but let's add Tim, Corey, and we'll choose a file, and that's going to be my image, and say create customer. Notice it blanks this out. T Corey over here, we have my image. Cool. It starts with a UEE. So let's come back over here, close this out. We'll go over to SQL Server Object Explorer, right-click on customer, and say view data. And we notice that we have Tim, we have Corey, we have a file name of tcorey/UEE. That's at .ping, and it was created by the user tcorey. So we've got a record in SQL now. Now, notice I stored the relative path. I didn't store the actual image. I just stored the relative path. And this is going to have a bit of a debate to it, and there are people who will say, well, there's times when you could. And there absolutely are times when you could put the actual object in your database. And there are people that will say, well, you want to keep your actual image with the rest of the record. That way it doesn't accidentally get deleted. You don't have to keep them in sync in some way. It's safer. And there is some validity to that argument as well. However, I will say that in probably 90+%, 95+% of the time, you don't want to do that. And here's my reasoning why. First of all, when you start putting files in your SQL database, it means that your SQL database grows at a much, much faster rate. Imagine how much data is taken up by this information right here. Not the file, just the information. Is it a kilobyte? Probably not even that, okay? We don't have a lot of data here. But this image right here is, mine's small. Mine's only 0.5 MB. But we've now made this record 500 times larger, probably more than that, but let's just be conservative and say 500 times larger. Now imagine if we upload, I believe it was Noah, we can actually look, but if we look at Noah's headshot is 1.5, Dan's is 1.5, Tom's is 1. So if we uploaded Noah's or Dan's, that would mean that the data in our row has increased in size by 1,500 times. So when it comes to backups, what does that mean? Well, we want to have a lot of backups for our SQL data. We don't want to lose data. We don't want to lose data even between backups. We want to have incremental backups and so on. So we have a lot of different backups that store data. So when you talk about the size of your data, you're talking about multiplying it by 10, 15, 20 times because of all the backups you're storing. So now all of a sudden a 1 MB file or row becomes 10, 15, 20 megabytes when it comes to your actual database plus all the backups. And that can really add up fast. Imagine if you had 10,000 or 1 million, let's just say 10,000. 10,000 customers. That's not much. I have more than 10,000 customers. So I'm a little shop. I'm a small business, and yet I have more than 10,000 customers. So if I'm storing 10,000, we're talking about even a 1 MB file. Back to the napkin math here, we're talking 10 gigabytes of just the images. And then if you back that up, to be 10 times, we're not for all the different backups. Now you're talking about 100 gigabytes worth of data backing up. That's a lot. Now, let's talk about what we're actually storing here, a profile picture. Is it the end of the world if we lost a profile picture? Probably not. Is it the end of the world if we lost customer information? Yeah, absolutely. That's a big deal. But losing their profile picture isn't as big of a deal. So when it comes to backing up these files, backing up the customer profile files, I can have a different level of backups for them. I can say, you know what? I'm going to back these all up once and then just do incremental backups for any changes that happen. That means that if I have 10 gigabytes worth of profile pictures, I might have a backup size of 15 gigabytes or less of storage. I might even just have 10 gigabytes and say I've only ever got the latest version. That way, if something happens, I can restore one version. And if I go more than that, we have a problem. We have to deal with it in another way. Maybe it's a little too loose. Maybe I want to have 2 or 3 versions. But now we're talking about 10, 20, 30 gigabytes instead of talking about hundreds of gigabytes. Even worse, when it comes to SQL Server, when you have a lot of rows, you can get to the point where your database takes longer to back up than it does hours in the day. I've seen this happen, or especially hours in your backup window, where maybe you have 3 hours to back your database up, and it takes 2 hours and 57 minutes, or even worse, 3 hours and 10 minutes. That's even worse. But that happens all the time for businesses. Well, if you were to add images to that, we're now talking about 24 plus hours. And you can't, have a database backing up for that long without having major problems. So the complexity goes up. It just makes a mess. So I would encourage you, let's just use the relative path to a storage location for your file. This will also mean it makes it very easy to move your files around, because notice it's just tquery/ in the file name. It doesn't say dtemp storage. That's what we store in our app settings.json. But imagine for a minute if I want to change where those files are stored. If I want to put them on a different drive or a different location somewhere else, even a cloud drive, doesn't matter. I could change that very, very easily by just going into app settings.json and saying, change it here. And now we're good to go. SQL Server doesn't have to know about the change. And we're going to see that in the next video when we talk about in 2 videos, I think it is, when we bring the data back and go store or display it on a page. So we'll talk more about that coming up. No, in one more video. Yep, this next video, where we actually display this on a page and say, hey, here's how you bring it back, and we'll kind of run some hiccups there, and we'll talk through how to display things from the database in a way that is safe, but also is in a different location than where you store them to originally, or a different path at least. So I would encourage you to think this through. Don't just flippantly say, oh, it's just safest to put it in the database. It's really not. It's really pretty unsafe. And it works great when you're in development. It works great when you have a few records. It works great when you have a few hundred records. But when you get into an actual production situation where your business has been running for 2, 3, 4, 5 years, and all of a sudden you have 20, 30, 40, 50,000 customers in your database, that becomes a problem, even if it's just profile pictures that you're storing. Now, again, everything has an exception. So there's no one right way. I'm not saying this is the only way. Because if you're talking about very sensitive records or records that are very, very important to keep with everything else, then yeah, you may be putting those in the database. But don't just blithely put everything in the database. Think through your data, and if it really needs to be there, default to not putting it in the database. And then see if you're in that 5%. And be very careful about making sure you're in the 5% before you decide to put it in the database. Okay, so that's how to put data into a database. Pretty simple stuff once you get down to get through all the setup. But in the next video, we're going to load the data back out of SQL, and we're going to display it on the page and see how to work with those images on a web server and see how we have to change some things up in order to make that work. Okay? Thanks for watching. Thanks for being a part of the series. Make sure to get the source code down below, and also check out that playlist to make sure you have an update in series when the next one comes out. All right? And as always, I am Tim Corey.